Okay, so this is probably one of the most important slides of this lecture for sure, but also of the course. So let's spend some time on it. And before we actually start looking at this slide, let's first reason a bit together. So I just said that you have one CPU core and that is all the time changing the program it runs. Now, the way it does this, it's not really that different from the way we do things in our lives. So if I am preparing dinner, okay, let's say I want to cook some pasta. So I have a set of instructions that I need to follow, and I'm going to run one instruction after the other. So first you put the water, then you you warm the water until it boils, then you put the salt, then you put the pasta, and blah, blah, blah. Okay, I'm going to do one thing at a time, and let's assume this is what I'm doing, okay? And I might get interrupted. Let's say my daughter, she needs something, okay? So she calls for me and I stop paying attention to what I'm doing and I start paying attention to her. Before I do that, I will store somehow information about what is the last thing or the last instruction I executed about preparing dinner, okay? So I will memorize, for example, that the water is warming up, but I have not yet put the salt in it. Before also talking with my daughter, I will also switch to the relevant context for my daughter, okay? I will probably, I don't know, check what she has in her hands or what it is that she needs or something like this, okay? So I will say, stop preparing dinner, start taking care of my daughter. I will do whatever I need to do with her. At a certain point, I will be done, okay? I might need to maintain some information about what I just said to my daughter because maybe I said go pick up something and I need to remember what that something is. And then I will load back information about where it was with the pasta. And it was, the next thing to do was to put the salt, okay? So what I described, it's called in operating system a context switch, okay? And this is what is happening all the time in each CPU core. So now let's look at the slide. There are a lot of terms here that will be introduced in the next video, but it's simple at the end of the day. Here we have two processes, okay? And they're called processes, not programs, because these are running and you can run the same program multiple times and each one is a different process, okay? You see that interrupts and system calls appear here too, okay? And you see that there is this PCB, which stands for process control block. And each process has its own process control block. You have process 0, and there is process control block 0. You have process 1, and there is process control block 1. So what is happening here is that you are executing, or the CPU core, sorry, is executing process P0. At a certain point, something happens. Okay, it can be a system call, an interrupt. So this is my daughter that calls for me. And what the operating system does is that it saves the context, the state of process 0, and loads the one of process 1. So it does a switch in the context to move from process 0 to process 1. Then it starts executing process 1. And when it's done, it stores the information about process 1, loads the information about process 0, and then starts executing process 0 again. Now, there are important things here you can already see. Each process can be in a different state. Okay, sometimes the process is executing, sometimes the process is not. So it could be in an idle state. Also, you see that there are periods of time during which no process is running. Okay, this is the time it takes to store the process control block and to reload the process control block of another process. As you can imagine here, these times need to be minimized, right? If you spend most of the time doing this load and load of PCBs, then most of your CPU time is just wasted doing context switches, okay? As we will discuss during the course, there is a very tight connection and cooperation between the operating system and the hardware, and that's why they can actually happen extremely fast, so fast that you don't actually perceive them, and you have this feeling of several processes running at the same time when they are not really running at the same time. There is one more important thing here that might sound strange now, but it's important. I'm talking about the operating system as the one that decides that it's time to stop running process 0 and start running process 1 and do this kind of things. The problem here is that I'm simplifying a bit stuff, because the operating system is not an oracle or an entity that lives outside your computer. At the end of the day, it's a bunch of instructions that you execute as you execute any other process. So if you look at this image here, well, where do you see the operating system? What does it mean the operating system decides that it's time to stop running process 0 and run process 1? If process 0 is being run, it means that the CPU core is running process 0. If you assume that you have only one CPU core, okay, because you had operating systems even when you had computers with a single CPU core, how does the operating system take a decision about switching a process? Well, as I will explain, okay, one of these two processes, or even both processes, might actually belong to the operating system. So you might be running process 0 and you want to read something from the disk, then you do a system call. The hardware puts your process to sleep and wakes up the process that belongs to the operating system, and is the process that is about reading something from the disk. Okay,